Okay, for people who are joining this live stream, this is an internal design review of SPARQL and related graph store functionality for a future version of Wolfram Language. So let's get started. So Tony, do you want to describe what this all is here?
Yes. So the graph store package is divided in 3 parts. One is the IRI, which is a generalization of a URL. That is a basic building block. And then there's RDF, which allows making statements about resources, the resources that are identified by the IRIs. And later there's SPARQL, with which you can query RDF graphs.
Okay, so the example here we have is from Wikidata.
The first one is from Wikidata, and the other IRIs use different vocabularies. Like the second one, Monday, is from using the time ontology, and the other one uses schema.org vocabulary.
Okay, but so these things have no particular alignment with our whole world of I mean, for example, Wikidata, we have some alignment with our entities. Is that true?
Maybe Alan could comment how far that is, but
we do. I mean, in many domains, we have IDs for Wikidata and Wikipedia. I mean, again, we haven't exposed those in a useful way yet, partly because we've talked about external identifier or IRI, and we also met recently, and several of us on this call looked at IRI and external identifier and thought they're both fulfilling some of the same function. So we might want to use IRI as the way of exposing and looking up those going between entities and identifiers, but that's something we should discuss.
I don't think that's right. I think IRI is more specific than external identifier. I think external identifier applies to lots of kinds of things that have no SPARQL anywhere in sight. And I would think IRI is a special case of external identifier that, with certain special properties that are relevant to the whole RDF SPARQL type world. Okay, so let's take a look. So, I mean,
can I ask? There is something I haven't understood. Are we planning to put this into the system context?
So right now, at least from our last meetings, the idea was that we have a graph store context, or maybe under a different name. Yeah.
I'm asking because for SQL, we're kind of in a similar situation that we have developed a layer that is not quite user-facing, that is closer to SQL, and the plan is just to expose it through entity store.
Yes. Well, I think the same type of thing is what we should imagine here. That there's some kind of graph store mechanism that we expose where, it may happen that there's an externally sourced graph store, just like it may happen, as is usually the case for the SQL thing, that, I mean, the world is full of SQL databases. The world's a lot less full of, triple stores.
Yeah. So one interesting development is that one plan is to use SPARQL to query relational databases, or at least make it possible to do so by using R2RML, the mapping language for relational databases to RDF. And that one uses
what's the benefit of that?
The language is in some sense different.
Yeah. And our native query language is yet different again, and has lots of things that we're making a big effort to map. Kind of the strength of our native query language is much greater than SQL, but we're mapping. We're trying to understand how to slice off a piece that is compatible with SQL databases.
Yes. So, so before I forget, so the whole purpose of this meeting should be that at some point we get to the SPARQL query language. The last meetings we have more talked about the why, but I think that SPARQL is a pretty nice language that we should consider carefully. And
used just by all of 25 people in the world. I mean, look, there's a reason that I mean, there exist certain external triple stores that people have built. The question of should we take our semantic relation framework, for example, and make it into something like this is very unclear to me. Very, very unclear. I mean, zooming out a little bit, I think it's interesting for us to study what happens with these things, and it's good for us to have, the three examples that will always come up over and over again of where there are triple stores. Sure, it's nice to be able to import those. I'm slightly, there's a, well, okay.
But this isn't kind of the main use. The main use would be to SPARQL-like queries against our own entity stores.
Yeah, well, that I'd support. But that needs a wrapper in the same way that we have entity store wrapping SQL databases. It's something that makes complete sense.
Yeah, and also, I mean, there are other types of graph databases that are probably more popular than SPARQL. Or rather, other types of query languages that are more popular than SPARQL nowadays. And so I think that getting too close to SPARQL, at least in the system functionality, would be painting ourselves into a...
Yeah, it's not the right thing to do. I mean, okay, let's understand. Let's see what we can learn from all of this. And let's see what functionality we can abstract from it that is usable. Okay, there's probably, in the end, will be a low-level thing that allows people who are SPARQL enthusiasts to, to make use of those capabilities in our system. But the more interesting thing is things that we can build on top of this that actually fit properly into our system. So let's try to understand what you've got here, okay? So I think I understand these IRIs. So now let's take a look here. What on earth is all this stuff?
So the next thing is an example of an RDF graph written in symbolic form.
How do I see the graph?
It's a tricky question how to visualize an RDF graph. So there are certain approaches, and we'll later see one of them. Yeah.
Is it a hypergraph or is it a regular graph?
It's some sort of hypergraph.
Generically a hypergraph.
Yeah.
Okay.
So in RDF, you usually want to describe resources using existing vocabulary. And what you see there, for instance, banana is of type fruit. Yeah, that is one of the typical things you do. First, you state what the objects are that you have, and then you give a label for the humans if they want to read it.
Yeah.
And you can also import them. That's one of the possible formats, turtle, what you see here. And that's an example that we just discussed internally.
So I mean, having a turtle importer sounds like a fine thing, but what's it going to turn into? I mean,
it's also an RDF graph, and the question that we are wondering internally, for instance, is how can one?
Okay. So this is a typical RDF triple, consists of, if I'm seeing these triples here, it's a, it's a thing, a relation, a thing. That's typically correct? Okay. I don't know what an RDF blank node is. What is an RDF blank node?
So in the graph, you always have nodes in every position of the triple, but some of them don't have an identifier. You just state their existence. And then you need to link them to the other nodes in the graph if you want. That's why you give them a label, but this is not an identifier.
I wouldn't call it a blank node. What's that 100 there?
So maybe if you look in the import, you see it a little bit better. So let's say if you want to say
that's a literal of some kind.
Yeah.
Okay.
So literals are also some kind of node, but yeah, they're distinguished.
Right. So, in the, I mean, if I'm to be a little bit snippy about it, the back in antiquity or something, Aristotle, well, people, decided that logic represents everything in the world. And this is now triples, and this is related to that, represents everything in the world. I'm not very convinced. It represents certain things, just like, people could say, well, an SQL database can represent everything in the world, which is, again, fairly not convincing. But look, it's a definite kind of thing. It's a bunch of triples. And I understand, and that's interesting. And I wish it had more obvious uses, beyond the fairly few examples that get trotted out every time, so to speak. Now, as you say, well, let's take a look down here at, these are the queries, right?
Yes. So before we imported some graphs or constructed some, one is the fruit graph and the other the person graph. And here we see what the syntax is. One of the query forms is SPARQL select, which returns a list of solutions. Yeah?
Yep.
And these solutions are basically bindings from variables to the values in the graph. Oh, and here in the details section of SPARQL select, you can see what are all the possible patterns that you can form, starting with a triple pattern, a basic graph pattern, and then recursively grouping any pattern type, filtering solutions, having optional parts of a pattern, path, and so on. Subqueries.
So here in this RDF triple thing, so fundamentally what you're trying to do is you're trying to instantiate these kinds of things in,
So there's a distinction between the RDF blank nodes and the SPARQL variables. So if you scroll down a little bit, if you see in the SPARQL query, in the SPARQL select, yes, there, the question mark, that is a formatted version of a SPARQL variable. And those are instantiated. So you're basically trying to find a match, and then you check.
Yeah, right. So this is like our cases, but for, what we were discussing before, which I liked a lot better, is trying to understand from our symbolic expression structures or our graph structures, for that matter, how to put in, pattern variables.
Yeah, I investigated that for quite some time, and it turns out that these variables in SPARQL are closer to what we have, the quantity variable that we have. These are basically things that appear in a formula, like in formula data, because they can appear both on the left and on the right-hand side in some sense, while patterns are more like for rules where you have the full pattern on the left and the name of the pattern on the right-hand side. So these SPARQL variables are closer to quantity variable.
Well, or to algebraic variables, which can appear anywhere.
Yes.
But so you're essentially trying to solve a graph equation of some kind that says, this subgraph, you're trying to figure out, I think it's more like that.
Yeah, so what you have here, and again in the SPARQL select details section, the basic graph pattern, that is the tricky part. And there's where you do some kind of subgraph matching. All the others are built on top of the basic.
Sorry, which
pattern.
one is the
second row
pattern here?
No, one above, just the basic graph pattern. Yeah. The others are defined recursively in terms of joins, for instance. So here's an interesting example that we try to model using entities, and it's a little bit tricky to do it like that, but quite natural using SPARQL. Like asking, what are all the important
this one here?
No, the one above, the query above. Give me for some company all the CEOs of, and together with the year. That is pretty tricky to formulate using entity queries, but it is pretty easy to read and to write using SPARQL.
I guess. I mean, we've never tried to build out things like this in terms of entity queries. Look, I mean, for the 25 people who know how to write SPARQL queries, this is great. I just don't think it's it's a very different situation from SQL, for example, where there are millions of people who know how to write SQL queries.
So one thing I noticed is that when writing SQL queries, if you go along relations, you usually start nesting the joins. And these nested expressions get pretty deep, and then it's difficult to modify them. While in SPARQL, you just keep adding triples or triple patterns to the list. Yeah, to the
I know. I mean, there's advantages to that kind of thing. Okay, look, I noticed we have somebody who dropped in on our live stream saying that they desperately want this functionality. I'm now going to ask. I'd be curious what for, because that's sort of the challenge that I'm seeing here. Is there are a very limited set of people who have SPARQL triple stored databases effectively. Look, I mean, what is clearly the case is that shipping this as some kind of package that people can use is clearly a win. The question is, how much effort should we go to try and integrate it properly?
I guess the next thing is make it work on our own entity stores.
Yes.
Formulate a non-trivial query that you can't formulate right now within the entity property world and make them expressible through a SPARQL select and then apply them to an entity store.
Right. And then ask the question, what do we imagine? I mean, one thing is going from natural language to this.
Yeah.
Another thing is going from some sensible Wolfram language thing.
Correct. That's then the next question.
Basically just a wrapper around SPARQL.
Yes. Like what would be our ideal Wolfram language version to do it?
Right. Well, I think we started talking about that in terms of graph patterns.
Yes.
But we didn't finish that. I mean, we sort of gave up and said, oh, well,
Yeah, the reason was that the graph pattern matching that we can do is basically what the basic graph pattern stands for. Again, in the details section. But all the other things are hard to do. That is an example of visualizing graphs. So normally, if you try to visualize millions of edges or even billions, you won't see anything. So this is one approach to visualizing graphs, by showing what are the classes in your ontology and what are the properties and which classes they link to and from. Yeah. So if you import some random data set that you find in the internet, you can check how does it look like.
Wait a minute, there aren't a lot of random data sets on the internet because there just aren't a lot of RDF things. I mean, for example, let's say I take your fruit example from up above here, right? Which was, is this the whole graph here? Right, so I take line 9, right? So what I want to do is take, can I literally take line 9 vowel graph?
Yeah, but it won't show anything. So it will be empty.
Why? Okay, well, you're right, it's empty, but why is that?
Because I haven't put any effort developing that ontology nicely. So I would declare, okay, what are my entities? What are my classes? I don't have any class relations, and I haven't declared what the properties are. So it's very experimental.
Okay. But so can we take an example live from something in Wikidata and visualize it? What is that entity? And how do I get a lump of the Wikidata graph?
So you should be able to say import of that IRI and get something back. However, you have to specify a content type so that it knows you are requesting, let's say, turtle. Yeah.
What the heck is that?
So this one is just some JSON, but what we want is some other form, and you have to somehow tell Wikidata that it needs
to emit turtle. So this is not, no, that doesn't work because that
because we haven't set the content types. That is something that we have to.
Okay, but so what you're saying is that Wikidata does not expose its turtle unless you ask it to. Is that correct?
Yes. So what we can do is using either write a wrapper, our own, and then use something like URL execute and specify the accept header and say turtle or whatever. And then we would get an RDF graph that describes that IRI. And then we can visualize it or whatever.
Okay, so we got a couple of interesting examples from Michael Hale and Carl Lang on the live stream here. One was about car data. One is about popes and cardinals. See, both of those kinds of things, like car data, for example, we have done a huge amount of work now to actually make, I have no idea what, I don't even know any types of cars. Let's see. Let's try that. Is that a type of car? I think that's a type of car. Either that or it's a type of turtle. I don't know. Why isn't that? Did I misspell that?
Cars are not yet exposed.
Not exposed in the language.
So they're in Wolfram alphabet, they're not exposed in the language. So if I were to do that in, so if I were to say the same thing, well, if I were to say the same thing here, then I would see all kinds of information. Is that right? What is our plan for exposing that in the language?
I'd like to do it now that we're documenting entity types. It's been a hard thing to tell people how to use without having that documentation.
Right. I mean, the problem is, you know, I mean, Wikidata is a much messier business than what we end up having, but there are things that will be in Wikidata because they are messier than what we have. You know, I think, so if the goal is, you know, just like we have Wikipedia data, you know, if what people actually want to do, if the sole example of RDF that people care about is Wikidata, there's an argument that, you know, we should be doing something more like what we do with Wikipedia data, which is, you know, nice and, you know, well packaged for that particular purpose. Like, for example, in this case, obviously, we've got a mess here because we're, you know, we didn't tell it to, you know, talk turtle, so to speak. Am I making sense?
Yep.
So, I mean, if we were to say, you know, Wikidata data effectively, and have that be a thing that allows people to, I mean, what would we do? Just imagine that we were doing that. Just imagine we were exposing Wikidata in some way. What would we want to expose around it?
So the immediate thing that comes to my mind is having a nice table. Like when you click that IRI, you will also see on the web. So we can show the same information. But that wouldn't be too useful because people could also look that up on the web. The real power comes if we can write complicated queries, like, you know.
Well, I understand that, but the question is, are those queries being written in SPARQL or are they being written in our language?
Why would they? I mean, the thing is, I think that it would be a lot more powerful if we abstracted away from SPARQL. And like, for example, there are ways of translating some of the SPARQL queries to SQL, not necessarily efficiently. And there are other graph languages, graph query languages. And so,
okay, let's understand the endpoints here. Okay, first point is there are people who have SPARQL databases that they want to make use of in our language. You know, that is essentially, you know, an import type story. You know, that's something where effectively we are, you know, people want to be able to do a better job than this of importing something that comes from Wikidata and dealing with it in our language. And if part of that import has to do with you know, being able to run SPARQL queries against a SPARQL database before it comes into our language, then great. You know, so I think that's one point is insofar as there is existing SPARQL material out there in the world, RDF material, whatever out there in the world, you know, we should let people connect to it, just like we let people import JSON and XML and who knows what else. the next question is, do we want to make use of, do we want to actually have a, SPARQL stuff running within our language? For example, do we want to make our own entity stores, accessible as SPARQL endpoints? I think that's kind of pointless. I think that's
yes and no. Depends what you mean by this. I think if you have a collection of entity stores of different types with connections in between, making them accessible as one giant net with connections rather than as a set of products, I feel like that's pretty nice.
If we can make use of that in our language in a reasonable way.
Yes.
Right. But I mean, that requires a build out of essentially, and in our language, the expectations for what can be done with graph matching are definitely higher than what one would expect in the pure SPARQL world.
And also, I guess that our current built-in entity word still looks a lot more like an SQL database. So would it make sense to expose entities as an SQL database? Maybe. Probably the performance would not be great.
No, it is pointless. I mean, it's some.
Okay, but I feel like we have put a lot of energy over the last years to make property values entities, if they are not quantities, which is kind of already a good canonical endpoint. And the more we do this, the more we have in principle a connection between things,
absolutely,
but not in practice.
Yeah, but that's something that is very easy to represent in SQL. Like,
we're not going to use SQL for that. I mean, it just doesn't. Okay, let's zoom out a bit at what we're trying to achieve strategically. I mean, first point is to have this whole package that Tony has developed be made available to people seems like a fine thing to do. It is something deeply in the world of SPARQL and RDF triples and so on, and people who don't understand those things aren't going to be able to use it. And that's okay. Now the question is, do we want to promote it to something that people who don't already know about RDF will be capable of using?
Yeah,
right? And that's a whole separate issue.
Yeah, but can I try to separate? There are two different questions to RDF and SPARQL. RDF is a way to store data, and SPARQL is a query language. So RDF is not particularly interesting per se, and many times it can be built on top of SQL.
Mm-hmm.
Of classical databases. SPARQL is a lot more interesting, and it's not the sole player in town that can do graph queries, because it's terrible to do things like transitive closure in SQL. So if you don't know how many hops you need to do, like if you want to ask a question like, is X a relative of Y, in SQL, it's almost impossible to do. I mean, there are ways of doing it, but it's like understanding the math is crazy. So this is where I think we should take the value of all this work and say, how do we, however are things stored and whatever the query language is, how do we represent things that are effectively transitive closure questions? This is,
yeah, I know, which is what we were talking about before with graph matching, but somehow that got diverted because why, Tony? I mean, we were starting to look at actual syntax for representing paths and graphs and patterns for paths and graphs. Why did we divert from that?
Yeah, basically two things. First of all, these RDF graphs are hypergraphs and not the graphs that we have in the Wolfram language. But the other thing is that SPARQL has many more features that are not really compatible with existing pattern matching technology.
Like
let's say subqueries. So for that, we would need an equivalent pattern matching construct, which is something similar to grammar rules, but for general expressions and patterns.
Specifically what?
That, but it's
no, specifically what? I mean, look, if we're going to integrate this, these are the kinds of problems we have to solve, and they're comparatively difficult. And eventually we're going to want to do this. But, you know, from a timing point of view, the stuff that you have here that is essentially a compatibility bridge with the SPARQL world seems perfectly sensible. Is it almost finished?
We can start writing queries against existing SPARQL endpoints now. We are working on some performance. RE is working on getting some new importers ready so they are fast enough. Yeah. But I think we can have pretty soon a first version.
So we could have something analogous to our XML functionality that is essentially this as an import type functionality. Is that right?
That means without any of those symbols?
I don't know. I mean, possibly in their own context. I mean, what we've done with XML, yes, which I don't consider to be totally satisfactory, is, I mean, you know, what is it, from 15 years ago or something, we've had the whole XML import. Well, we have this whole XML element business, which is what you get out from doing an XML import. I don't consider it to be super satisfactory. I mean, people certainly use it, but I don't think it's, you know, the issue is XML is its own world, with somewhat different structure from generic expressions and so on. Actually, so similarly, this is the same type of thing.
Yeah, actually XML element and the technology is pretty useful. I just wrote the RDF XML importer on top of XML element. I think we could improve certain areas of XML element. Yeah,
I don't disagree. But I'm saying that if you don't know XML, you know, you don't care about XML element. It's not a general feature of the language. It's something specific as a bridge to the XML world, which is similar to what you're doing here with RDF.
Yes.
So, I mean, okay.
Stephen, yes and no. I at least agree 60%. But none of the XML element you could apply to generic Wolfram language expression to do things you couldn't do otherwise, which would be the case for SPARQL things.
If you can convert our stuff out to SPARQL.
No, if Tony can do this under the hood.
Yeah.
What do you mean? So what will be the case? Okay, so look, one example is you're taking Wikidata from the outside, you're representing it using these RDF triple things, or whatever else, and then you're doing operations that are, you know, nominally Wolfram language operations, but which basically require an understanding of SPARQL to be able to use them. So that's one case. Now, what's the other case you're describing?
I was more thinking like, while there's still a way to go, writing a SPARQL-like query, still in the SPARQL world and SPARQL syntax that Tony has, but against, say, our own built-in entities.
And how would that work? I mean, we would have some IRI that's an exposure of our built-in semantic relations framework?
So we would need a correspondence between entities and IRIs. And then the idea is that we can use entities or IRIs interchangeably.
We would use entities rather than IRIs.
Yeah.
Right, as the object here. Just like...
Yes, we could use an entity property there, or even an IRI that stands for the entity property. Basically interchangeably, however the user prefers.
Yeah, but we don't have IRIs. We don't have not defined IRIs for our entities. We certainly we actually have done that a decade ago almost. We did something like that and then decided we didn't want it.
But in this case, there's a pretty natural translation between the left IRI as an entity, the middle IRI as a property, and the right one as a property value.
Sure. Yes.
So we could be smart enough to recognize this.
Yeah. Or for instance, one proposal is if you enter an entity in Wolfram Alpha, you usually get information about that entity. So the Wolfram Alpha address is in some sense a natural IRI for that entity.
That's what one of the things we built a long time ago. Right. I don't know. Okay. Again, look, this project, you know, what do we think is the big payoff from this project?
I think the big payoff is we have at least a working underlying implementation for a potential future much more complicated query language against our entity framework.
Okay.
Even if we don't have yet the top level language to express it.
Fair enough. Okay, but so look, it seems like the steps that need to be gone through are, one, package this up so that it can be used by people who have existing, you know, SPARQL endpoints and so on. there is a question that needs to be addressed as to whether this is all in the system context and whether we actually have things like SPARQL select in the system context.
I think for now we put it in our own context for playing around.
I tend to agree with that. I mean, that's now for XML, I think that's what we initially did. And then years ago, we took it out and put it in the system context. What is this question mark syntax doing? What is that?
So this is actually in full form is a SPARQL variable and then a string name, in this case, end. And this is too verbose. So we made a nice formatting that is similar to the SPARQL formatting.
Oh, boy.
Yeah, these things, of course, must be all changed for the language. There's no question.
What the heck is that? What
you
is
can
it?
check the full form. Oh, yeah.
So it's some kind of, oh my gosh.
Because some months ago, we still used just naked symbols for variables, and that was not nice. So this one is not correct.
Yeah. Well, this syntax, I mean, it's not typable in, you know, it's not a good idea. You know, we can have some kind of print form for these things. You know, for an RDF triple, I mean, this is not very consistent. You know, this is not a good idea. We should not do this here. You know, for entering the thing, it should be, if it's SPARQL variable, that's what it should be. And in terms of a print form for this collection, you know, for the RDF triple and so on, you can have whatever print form you want. You can have it be perfectly beautiful and not have a, you know, quotes P, et cetera, et cetera, et cetera. Why are there two elements in these IRIs?
So it's a namespace and the identifier in that namespace. It's shorter than writing out the whole IRI.
By the way, one thing I was thinking is that we kind of had a similar problem with template slot. And I guess, Tony, you have a parser for SPARQL.
Yes.
And so maybe what you could do is like just let people write SPARQL and then parse
well, that's what we do. I mean, in the case of regular expression, right? We let people write pure regex strings if they want to. And
yeah, it's basically the example that you see on the screen here.
Yeah, but we don't have a regex parser that can turn a regex into a string expression. In this case, we do.
Right.
So you can then reason about it, like and manipulate it symbolically. And the same goes for I don't know, string template or XML template, all that stuff. You can type in HTML instead of XML elements because it's faster, and then we parse that and we turn that into XML elements.
One question again about the SPARQL variable, the formatting. So if you check quantity variable, it also has a formatting. So
yeah, great, but that's something that's deeply built into the language and supported all over the place. This is not. This is something which is basically, you know, some bizarre variant of our built-in pattern variables that because SPARQL doesn't happen to support our built-in pattern variables, we have to do it differently. And it should not be something that is, you know, I mean, we could have had this syntax 30 years ago to represent something. We don't. You know, let's not introduce it as some weird SPARQL variable thing. And, you know, it should be entered like this.
Well, users enter it like this, but later, if you hit Shift Enter, it formats like that. So that's how I entered it.
Okay. But this isn't, okay, fine. Whatever. I mean,
so
look,
a user wouldn't type question mark.
Okay, fair enough. Okay, let's bigger picture. What is it going to take to get this to be usable as a package in its own context, in some kind of SPARQL context, with all these symbols in that SPARQL context? Is SPARQL the right name for the context?
So this graph store project, how we call it right now, it has basically at least 3 components. One is IRI, which is completely independent. Then there's RDF, and then there's SPARQL, which builds on top of RDF. So it's basically 3 things that we somehow group into some context, currently graph store. But potentially in the future, there could be support for other graph languages. So I'm wondering, whether it should be generic like GraphStore or something more specific.
I think if we're going to have these kinds of functions, then it should be specific. Because basically, this stuff will not be usable except by people who understand SPARQL. And we're not trying to make it usable by anybody else. You know, if we were trying to do that, we would actually build it into our language with our own mechanism, and it wouldn't be called RDF triple. Am I making sense? You know, we would have something that's called, I don't know, I mean, didn't we start a design that had things that weren't, you know, RDF branded ways of representing relations?
Yes, but we talked with Charles.
Okay, so we've gone backwards, is basically what you're telling me. I mean,
Yes.
The last time we talked about this, which was like 2 months ago, we were much further ahead on figuring out how we could actually integrate this with the language. We've basically reverted to something which is a thin wrapper around SPARQL. Is that a true statement?
It's actually the pretty nicely designed symbolic language for SPARQL. It's not just a wrapper, but...
Fair enough. I'm not attacking that. I'm just saying,
writing
do I need to go look at my notes from this from before? I think I should go look at my notes from before.
I mean, we don't have much infrastructure for anything else than the graphs that we have right now in the language, which are pretty simple.
Absolutely.
So the real power of that language comes out when you write non-trivial things. Like I'm working on 2 SPARQL-based projects now, and using the symbolic form is so useful, especially when you
What symbolic form? You mean this form, like RDF triple and so on?
Yes. If you have to write queries or construct queries recursively, that would be a nightmare using string joins.
Sure.
It's really convenient, and it saves a lot of work having that symbolic form.
Right, but that has nothing to do with whether you represent it with question mark blah.
Yes, in code you don't see this question mark, you just write SPARQL variable.
Right, okay. But so just to be clear, you know, what we could be doing is trying to make action pattern. Okay, first of all, we've got, okay, so what are the steps? We've got hypergraphs instead of graphs.
Yep.
And we've got graph patterns, which we don't have right now. Right now, we have patterns for trees, but not for graphs, right?
Yes.
Or, yeah, mostly. And then we must coordinate the whole thing with smart and smirks.
With what?
The
chemical data
the
stuff.
pattern equivalent, yeah, exactly.
Which is then patterns for pieces of chemicals, yes?
Correct.
Which are graphs, not hypergraphs, right?
Good question. Smarts are graphs, smirks have our hypergraph elements.
What are smirks?
For instance, for chemical reactions, where you have multiple things in and multiple things out.
Yeah, right.
In the hypergraph level.
Okay. All right. So what are we trying to decide in this meeting?
I think one of the bigger questions was the context. So I think we said...
And the design of the language overall. So far we had some people internally use SPARQL and RDF, but we still have to look over all the names, at least some of them, and some ref pages.
Okay. What the heck is an RDF dataset? That's yet another new thing.
Yes, so if that's the most general form, so you can generalize
a documentation page for that.
Yeah, I can send it in a moment.
How many symbols are there in your design here?
Currently 39.
Oh my gosh.
But if we put them in own context, it's not such a big deal.
No, it's not. But I mean, this is a giant SPARQL subsystem, basically, which is, oh boy. Okay. All right. Well, look, so given what you just said, there is no question these things are going in their own context. Then the question is, okay, so we do that. We try and make something where Wikidata in particular is easy to access that way. we then try to start potentially exposing some of our internal, entity structure to the system. Do we understand how to do that or not?
I'm working on it. It's a two-step process. The first step is support for R2RML, which means using SPARQL to query relational databases. And that one is achieved by using a mapping language in which you express how the relational database maps to to SPARQL on RDF. And once we know that, we can build on top of that to define a language or a simple syntax to define how to map entities to RDF. And using that mapping, we can then write SPARQL queries against entities. I have something ad hoc, but I like to improve that a little bit.
I think we need to talk about this project some more. I think, basically, as its own world of SPARQL stuff, I'm sure you've done a nice job mapping sort of SPARQL into a symbolic form. But this is far away from having something that's properly integrated. And, maybe we don't care at this point to have something that's properly integrated. And maybe it doesn't matter, because maybe what the main use is, people who already have SPARQL stuff, maybe we find some way to expose our stuff. Yeah. Michael, how much, this is...
I feel like the philosophical question is, there's no question that for practical purposes, what people ask us right now, our entity property factorization covers 90%. So, but we are not be able to formulate arbitrary, complicated queries against our knowledge base.
I know. So this is cool. But in order to get to the point where we can formulate those queries in an integrated way, we need to build out a bunch of other stuff. And it's not even obvious this is the right direction to build it in.
No, that's not obvious.
Yeah.
Right? It depends, of course, always on the level. But if you look at this, so the first one, as we already discussed, would be some kind of smart identification of IRIs versus entities, entity properties, and literals against quantities and other things. So then we would need a notion of RDF triple, which probably we should have anyway. Like right now you have an entity, have a property, and you have the result of the entity property value. But we don't have a nice container for the whole thing, which say would be for spoken result anyway, the most natural representation of the thing.
Yes.
Other than you build it yourself.
Well, okay, but there's one thing is to represent that entity property value thing, which we effectively have some kind of representation for in an entity store.
Yes, inside, but not as one thing. Like we don't have a representation of the population of Tokyo is 9.8 million people.
We do not. That is
That's
cool.
what I'm saying.
But then once we have that, yes, then we can make those pieces of that into pattern variables.
Exactly. Now we make pieces into pattern variable, and we collect a few of them, and then we feel like not too far away from a reasonable, nice querying language. Yeah,
right. But the way that would look, as we discussed ages ago, is something more like, right now, what we will be saying, so let's imagine that we had something that said something like entity query, okay? And which is something against our entity store. And it was, entity query, and let's say, I'm just going to make a entity assertion, let's say that that's what it is. And the entity assertion is that, entity property value, basically. And so then this would be something like, or actually what this would be is entity cases, something like this, a bunch of entity assertions, some of which have pattern variables in them. I mean, is this but this is not the most general form by any means.
No, but definitely not. We don't just want to get a couple of entities back. We want to get a fragment of which properties, which literals, which entities.
Yeah, I mean, this is exactly the stuff that SPARQL has been built to be able to do.
Right.
But, you know, merging that with the kinds of things that we're able to do. I mean, yes, it's just like we could say, let's turn all our pattern matching into regular expressions. Well, that won't work, right? Regular expressions can do a certain set of things. It's it's mostly a subset of what we can do. There are some things regular expressions can do which we've never cared to do in our, symbolic expression pattern matching, and it hasn't come up in 30 years. So it's kind of like we probably shouldn't worry about it. But it happens to be a thing that's some kind of weird, look back mechanism for regexes that got implemented a few times. Similarly here, there are things that people really want to do, and there are probably ornate things that people actually don't care very much about doing. And the question is, can we make a design that actually fits in with the full power of our pattern language and can deal with essentially this graph fragment matching stuff that exists here? And that is a complicated project, which it sounds like we were on a path to talk about a few months ago, and that seems to have been derailed from what I'm understanding. Is that right?
I wouldn't say derailed. I would say first we followed one existing one to have something, and then we can go back and make something that fits fully our language.
Yeah, but I still think that there is some confusion here. Like what you were saying is that we need to have some way of representing triples to be able to do graph queries, and that's not true. I mean, you can have it in a pattern language without having it for storage. Like it's just a matter of whether you store the adjacency list or you store the graph in some other way.
No, nobody speaks about storage. We only speak about the representation of the query.
Yeah, when you write okay. So
look, right now we have a mechanism. I mean, if we want to know, what country has a population, how would we do this? A population nearest to 5 million, right? So we would say, something like this, which is kind of a, what would it be? Nearest to, and then what would I say? 5 million here?
Yeah, 5 million people probably. 5 million probably will work.
And do I have nearest things I want? Will that work? I still think it's weird that what comes out here still requires an entity list. Great. Well, that didn't work. What did that just do? What did that just do?
Why do you run the entity list on?
It's a bug. I'll take care of that.
But that still shouldn't evaluate. You cannot run entity list on an entity because it's one entity.
No, you asked for 4.
Do you think that will work? What was the bug
that's
here?
One entity. Like the head is entity.
So make entity class anyway.
Yeah.
What should I do here? What should
entity
I say?
Class one line up.
Yeah, well, this is the same. This is where we should be spending effort to get it fixed. No, that's still not working. So what did I do wrong? Do I have to say 5 million people here?
Yes.
Okay, so if I say there, comma 10 or something, then I should get. So why is Norway not? Oh, I see. These are the things between, if I say entity value of that population, what I should see is those things being around 5 million. Okay, fair enough. Okay, now what would happen if I wanted to know the population in 1970 being closest to 5 million? Can I do that here?
You would wrap data around population.
It's really annoying that I have to say entity list every time here.
And you shouldn't.
Well, why do we need it?
Because you asked for a class, you get a class. You didn't ask for a list.
Now, why would you want to ever see the list? Like, why don't you?
But if I say here, entity list, will that work?
No, no. What I'm saying is that if you take the entity class and just ask for, say, name, like apply entity value to it and get name and population at the same time. Just take the entity class and apply to it,
Entity, comma, yeah.
Yeah, or you don't need to see the single entities ever. The entities are.
I mean,
this is the answer I want.
The single entities are not meaningful. Like what is meaningful? What you want?
The answer I want. I want to know.
No, the answer you want is what is the name, and that only happens to be the print form of that. But what you really want is the name of.
Well, I want to see the print form because I think that's what's useful.
But Stephen, this is because in this case it's a few. If it would be 10 to the 6, you don't want to see them. So that's not
correct.
True.
Yeah. What I'm saying is, in general, we're like with this pattern of having the single entities do something. We're educating people to do things always in 2 steps, and that's wrong. I mean, in this case, it doesn't matter because the population of Norway hasn't changed significantly between the 2 queries. But in general, you want to educate people to always do things in one go.
Okay, that's a separate issue. I mean, look, honestly, putting more effort into getting this stuff to be smooth seems to me a lot more important than this, kind of tentacle of SPARQL stuff. And, well, anyway, look, I think we probably have to wrap this discussion up. Let's package the SPARQL stuff to be its own separate context thing. I don't know how much design effort should be put into it, given, for example, it's not clear how much I can help with this because I'm not a big SPARQL expert. We were discussing ages ago, making sure we've talked to a bunch of, what the heck is all this stuff? What is this? What is SPARQL Ask?
So there are different query forms. One of them is SPARQL Select. The other is SPARQL Ask that just checks, does the pattern exist? And then there's also...
I mean, what does that have to do with the ask function in our language?
Unrelated.
Really? Well, why is it given this name?
It's following the SPARQL standard.
So we're basically just building a wrapper around SPARQL here, which is what I keep on saying. The word select happens to be similar to our select, but that's purely coincidental. It's not that similar, actually.
Yes.
But we are interested in having the functionality at our disposal, not the name.
I agree. So I think, in the theory that the only people who can use this are people who know SPARQL, then it's a fine thing to use names that they are familiar with. And, given that, just put it in the SPARQL context. Now, how do you get it to return something that connects to the rest of the system?
What do you mean?
Well, okay, so at the end, what's it going to return that can be connected to the rest of the system? It might be some list of entities or something that is...
Yeah, so in general, you get back nodes which are IRIs, but there's a special case called literals. And they are XML literals, and they map to our, let's say, dates, like in this case. And some literals, they don't map to anything.
Like what?
So users are free to define their own literals, and there's no way we can know what they meant. So it's their job to process them however they like. So this is very general.
Yeah. I mean, listen, you should be putting more effort into making sure that entity store works smoothly, that it maps into the database stuff, that there aren't bugs like the one we just found here, and so on. Those are mainline things. This, to me, is kind of more of an experiment. I mean, I thought it might turn into something other than that, but it really isn't. It's really a SPARQL experiment right now, which is fine. So let's get it finished and let's get it put in a SPARQL context with things which are admittedly SPARQL type functionality. And, just like we are doing, the Mongo link thing, this is a similar kind of thing where the Mongo link thing is very, visibly Mongo oriented, so to speak. And, you know, what we're doing with SQL is much more deeply integrated, and it's not, you know, full of SQL language, so to speak.
So in the databases, there's this prefix. It's not called SQL, but databases, at least one of the layers that I've seen. They also have like aggregation. And I'm wondering, shall we review that, let's say the aggregate operator, that they are aligned, or how much effort should we put?
No, I mean, it's not going to work. Look, you know, the effort to align what we're doing here between, you know, look, we either have to say this design is based on the SPARQL design, or we have to say we're actually going to make our own real design. Okay? We're not making our own real design. That's a lot more work. You're basically making something that is leveraging the SPARQL design, which is fine. It's just not something that, you know, can be deeply integrated. It's perfectly useful.
And the underlying technology can be reused in a future design that is ours.
Right. Which is fine. And we've done that many times before. But, you know, we shouldn't try to make it some kind of compromise where we're trying to, you know, and we certainly shouldn't do things which look like they're, you know, making some major change of syntax to support some weird SPARQL variable thing. You know, do the best job we can in the SPARQL context for all of these kinds of things. And let's get that put in as quickly as we can. Can we get that for version 12?
When would that be?
Well, in the next month or so.
That should be possible.
Okay.
Not perfect, but...
Well, that's okay. We can tag it as experimental and in its own context.
Yes.
And then people can use it, including us, and then we can slowly start experimenting. I mean, as you say, like the XML stuff, I don't consider that that was adequately designed 15 years ago or something, right? But as you say, it's still perfectly useful if you're prepared to, dive deep into the XML world, right? But people who are not XML experts are not going to be able to use it, except in a very stylized way in that particular case. And I think the same will be true here, which is fine. So what else do we have to figure out about this? You know, my statement is, yes, why don't you have it map closely to the SPARQL design? Don't try to make too many, don't try to have compromises where you're trying to map it into our design, and remove functionality that would be SPARQL functionality, because it isn't worth it. It's something for people who already know SPARQL. Make sense?
Yes.
I agree.
So it's a complete implementation of SPARQL 1.1, the latest standard. So it's passing all the official tests.
Magnificent. But it's basically our binding for that using our symbolic language.
Yes. It was pretty tricky to design it, at least until this stage. Yeah. Even so, it might not seem like it, but there were some very tricky questions, how to map certain things into a way that looks a little bit Wolfram language-like.
Example?
Like using function composition to have a SPARQL query and then an aggregation. There we're using function composition, and that looks a little bit different in SPARQL, or pretty different depending on how you look at it.
Well, do you like the way it works with function composition?
Yes, it's pretty natural how you see the pipe. Like first you start with the select, then you have some solutions, and then you continue transforming that solution. And then you can apply another aggregation and another, and so on.
Fair enough. Sounds nice. Look, I mean, it seems like with considerable effort, you've solved a bunch of these problems. The problem you haven't solved, which is frankly, I think is a year-long design process, is getting this thing to really map into, it's a big complicated process that involves us implementing hypergraphs and having, graph patterns and so on, which we want to have quite separate from this. And perhaps what we should be doing partly in connection with chemistry, partly in connection with other things, is starting off by having patterns in ordinary graphs. Forget the hypergraphs aspect of it.
That would be definitely the first step.
Right, which is its own separate, year-long process probably.
And it has non-trivial implementation issues.
Sure, I know. We implemented that like 20 years ago for these, space-time graph things that that I've occasionally worked on. We had a good implementation that worked for hundreds of millions of nodes and so on, for certain specialized cases. But yeah, it's non-trivial. Okay, what else anything else we need to figure out here? I mean, the question of the review of the design of the 39 symbols that you're talking about being in the SPARQL context. Let's see a guide page for that. And again, that guide page should refer directly into the SPARQL, your SPARQL 1.1 standard and so on, and should just say this is essentially a binding wrapper, whatever you want to call it, symbolic representation.
Yeah.
Because I think that's what, people will understand that, people can use that, it's all good. But we won't pretend that it's our own integrated thing.
Yes, so I started 3 guide pages, one about RDF, one about SPARQL query, and one about SPARQL update.
What's SPARQL update?
So it's the update language. So you can query or you can modify in RDF Graph.
Oh my gosh. Okay. And that's part of the 39 symbols, or that's another 82 symbols?
That's part. Everything 39.
Okay. All right. Okay. Okay. But so now, what is our ability to maintain our own SPARQL database, or are we mostly dealing with external pre-existing ones?
Internally, we already have some running, and they are used internally. At least by Aaron, I know. I don't know who else.
Okay, but so are we planning to actually host those ourselves in the cloud? Are we planning to have individual users host them?
I think a user can just set up their own SPARQL endpoint and make it accessible under a URL. It's up to them to find one product that they like.
Wait a second. That's a whole separate thing. Are we going to let them set up a SPARQL database that runs in using our SPARQL package? Or are we going to say, oh, you're on your own, build your own server, and then you can use our stuff to interact with that?
I think we haven't thought about this yet.
Yeah, we haven't, but the process would be something like you run one line on the command line to start that SPARQL program.
No, that's not going to work. So it's as a daemon type thing?
I think Tony and Stephen, you speak right now about different things. Okay.
Explain.
I think Tony is speaking within one session and you mean it as something permanent.
Well, I don't know. Tony, what do you mean? Are you talking about a sort of pop-up SPARQL database that exists only within the scope of one Wolfram Language session? Or are you talking about something that's a permanent thing, like a permanent database?
Yeah, it's something that a user can run on their machine or their server. And then they use SPARQL update to load a file or to insert some triples manually. And
then where does it live? I mean, is it in the local object store? Is it in some random special directory?
That would be independent of the Wolfram language.
But it's not. If we okay, can you create it from Wolfram language? Or is it something that has to pre-exist?
It's something like a SQL database that you have to set up somewhere.
Okay, so right there, we just reduced the number of people who can use this by another huge factor.
But it's one line on the command line to start it up.
You download it, not. It's setting up some whole thing with system administration, et cetera, and permissions, and so on. It's complicated.
Well, yes, if you make it public, yes.
Right. So, and then the next question is, does it run in the cloud? You know, how does it work with our cloud sandbox, for example?
as said, we haven't thought about this scenario at all so far. So
okay, but so
we cannot give them answers.
Okay, but so just to be clear, the scenario you have thought about is there is a pre-existing SPARQL database somewhere, SPARQL endpoint external to us, and you are importing things from it, like the Wikidata case. Or you've gone to a lot of effort, you've mirrored that thing, you've got a whole setup, you've got system administration around it, et cetera, et cetera, et cetera. Those are the cases that you've considered so far. Is that right?
Or how to view our own world through SPARQL classes.
Okay, but that's not the same as the SPARQL update thing that was just dropped on us.
Yeah.
Right? That's a completely different thing. That's a separate story. I mean, that's something we have not reached in the SQL world. In you know, our entity store mechanism in the SQL world, we're not doing updates there, right?
Not for version 1, but we're planning to implement them later.
I understand that. But as soon as we're doing updates, there's a whole complicated set of authentication issues and locking issues and, you know, synchronization and so on.
Yes.
Right? How does that work for these SPARQL things?
That's up to implementation of the SPARQL triple store.
Which we're not doing. And how do we pass through the authentication information to that server?
That can be included in the URL or in the HTTP request.
So in other words, we have to build something that gateways through our authentication mechanism, because it could be in, you know, in the headers, in the HTTP headers, it could be in the, you know, username and password, could be in shockingly bad security in the actual URL and so on. Is that right?
Yeah, basically like any API. Yeah.
Right, but then we've got OAuth to implement, et cetera, et cetera, et cetera, if that's really how that's going to work. This is complicated, very complicated, and not obviously worthwhile. Yeah, so I mean, I think we better see a list of the 39 symbols. Let's get that. Look, why don't you start? Okay, the path we're on very soon is implement this as a separate package with its own context that will be tagged as experimental and try to get it into version 12.
Shall I defuturize the ref pages and make them experimental?
No, you should put them as a package. Ref pages in a package, right? You know how to do that.
Yes, they're basically in the context.
Right.
Or
That
what?
should,
Yeah.
I actually don't remember how you do that, but it's the same way that database link works and Mongo link and all those kinds of things.
Yes, exactly.
Right. Yeah. Okay. So look, I think we're on that path. We should understand, you know, a nice smooth way to get Wikidata into this as an example, right? That doesn't involve import that, you know, doesn't know how to talk turtle, so to speak.
Yes, so that would basically be a function like entity value, right? So you have an IRI and then you ask for properties or you ask for a data set, right?
I would think so. And
Yeah.
maybe what we need there is something that is purely a different kind of function like Wikipedia data that works on Wikidata. If that's coming back as something which isn't even related to SPARQL particularly, but that might be a useful thing to have anyway. I mean, maybe Alan would like to comment on that.
I was just saying we should discuss with Alan and Johan.
And how would we call such a function IRI information or?
I don't think so. I think it would be like Wikidata. Well, Wikidata data is an unfortunate name, but that concept.
Yeah, let's have another meeting before we discuss this with Alan and Johan among us.
Okay, but I mean, that's something that doesn't really require, it requires just this turtle importer. It doesn't really require the whole structure of this whole SPARQL query system. Right? Or am I wrong about something?
Probably right, but I can't confirm.
What you get back is an RDF graph, and then you query it using SPARQL. if you use it in a
What about if you just want the actual data to be useful?
Yeah, you can write a trivial query in SPARQL. Just give me all the properties.
I know, but a trivial query to you in SPARQL is not achievable by most of our users. Right? There's a different class of people that know SPARQL and can write SPARQL queries from the class of people who just want to extract stuff from Wikidata, for example.
No, we understand the problem, but I don't think any of us right now has looked deep enough to make any discussion.
Fair enough. Okay. Well, look, I know this has been a somewhat long road getting this SPARQL integration to work, and it's. I mean, we've certainly been talking about it for more than a year. It's exciting to see it actually come to fruition, even though I don't appreciate it as much as I might because I'm not enough of a SPARQL expert. But okay, I think we're on a path. Get this documentation in a separate context for a separate package, tagged as experimental, and I would think that you guys can review it without me. And I'd like to see it again once you have it in the form of a bunch of guide pages and so on. And honestly, I'm not going to be able to do that deeper review because I just don't know this subject area well enough. And I think then after version 12 is when you get to start experimenting with using these kinds of things on our entity store. Is that correct?
Yes, that sounds right. So I have 39 guide pages, even if it's minimal examples.
Ref pages.
Ref pages, oh, correct. Ref pages, 3 guide pages. And that means today I'll experimentalize it, so to say.
Yep, and put them in their own package.
Yes.
And please get rid of some of these weird things about, that are, that like masquerade as being new syntax and so on.
Okay.
Okay, sounds great.
Okay, thank you.
Right, see you all soon.
Thanks.
Thanks to people with comments on the live stream.
Bye.
Bye.